and welcome to Converge. It's a very special meeting, not only because Jesse Harrington Au is here, but it's our 1-year anniversary. Hooray! Happy birthday to us. Yeah, a year ago, before a year ago, we decided to try and put on something a little bit different. So we were looking for innovation in the Bay Area, and instead of concentrating on a technology or a topic, we thought we would concentrate on the people that were making cool stuff. You guys. And so every month, or we usually have about 10 meetings a year, it's a completely different topic and hopefully something you'll enjoy. And we always see different faces every time, so it's pretty cool. So you'll see that's what we are all about. The team. So we have a couple of co-managers, myself and Larry, and then we have this great committee, and Jordan is our resident DJ and designer, and Tony checked you in, he's out there.
Stickers if anybody wants stickers, because everybody.
And Tatiana, raise your hand. Tati works at Google, and she's been, gosh, you started helping us. We used to be Sam Flash Cisco, so we used to be very much about Flash. So there's a whole community of Flash people that moved across to Converge. And then Michelle couldn't be here because she's stuck at work. So that's us. Oops. So if you want to connect with us and know what's happening, the best thing to do would be either go to our website or follow the Twitter handle at Converge-SF.
Welcome. Can everyone hear me okay without the mic? I'm a very handy person. My name is Jesse Harrington Au. I am the maker advocate at Autodesk. I still, after 2.5 years of being there, have no idea what that means. I do a lot of weird things with my job. I'm the top liaison for our relationship with TechShop. I build a lot of marketing materials for our consumer group. And I do everything there is to do with 3D printing and rapid prototyping. So if there's a process that is out there, I try to research it, figure out a way to do a project with it, and then see how we can push that boundary. Usually how to enter some of that digital market into more of the craft market. And when I say craft, I don't mean Etsy, I mean craft as in personal handcrafts, such as, we took a digital file and built a car out of it, using a lot of handwork and hammering work. Yes, and I'm going to show you that in just a second.
Okay. How many is it?
Cool.
That got my attention.
Excellent. So these are the things I typically like to build. We have a giant presence at Maker Faire, which is sort of heavily reliant on myself and my team. A really good team of interesting people that like to build on that. So last year we built a 12-foot tall Trojan horse made entirely out of cardboard. If you work around here, you might have seen that roll by because the Instructables office is right up here, and it came out of there and rolled down Market Street around Christmas time 2 years ago. So one of the programs I'm going to show you in a little bit basically does that for you, and it shows you how to get those files out so you can take them to a laser cutter or something at a place like TechShop or any hacker or makerspace and be able to develop those things. The picture next to it is a very, very close friend of mine, Blaine Denlow, who is the general manager of TechShop San Francisco. And a year and a half ago, he came to me and said, let's use the program that made the horse and that made the cardboard Buddha and the squirrel, and let's figure out how to make a car out of it. And so what we did is we took an old Citroen CV, we pulled the body off, and we made the bulkheads out of that program. So we had the model in 3D, and we just said, we want it sliced up. We need the files to be this far apart, and that gave us the bulkheads to then lay, Blaine took his old school crafting because he can't even answer an email, and I took in all the digital side of it, and we water jet out and CNC cut most of the car, and then hand put it together. And that's us in front of the Henry Ford Museum, Detroit, Michigan, where we had a really awesome experience and got to meet some of the museum founders who really wanted they're going to have the car there for a maker installation of, you can build your own automobile for $7,000 that gets better gas mileage than most of the cars in the market right now, which is crazy. So you'll see us drive around. We have it in town, so if you see us on the street, feel free to stop us and kick me out and jump in for a ride. Cool. So I want to talk a little bit about what the maker movement is, and a lot of you have probably heard the term maker movement. I'm sure everyone here has gone to Maker Faire at least once. Has anybody here never gone to Maker Faire? Never? Wow. Okay, it's so cool. It's like Burning Man for families. It's basically how it's presented. And this is an artist from the Bay Area who moved out to Detroit, and he built this entire thing. It's about the size of this room. It's all out of recycled car parts. It's called Gong Kiran, and just an amazing guy. That's the sort of stuff that we're finding at Autodesk is really inspirational to the next stage of entrepreneurs and the next stage of creators. So these are the things we're looking at very closely, working with artists like this to do Burning Man style art and to do things that just kind of free up these associations that we used to make with, blue collar work or guys in factories do that stuff. No, now everybody does that stuff. We need to get more people involved in that. So has everyone here heard of TechShop? Yeah, we're pretty close to it. So TechShop, for those of you who haven't heard, is a member-based community. It's sort of like the Gold's Gym for makers. It's sort of like this place for people that like to make. You go in, you pay a monthly membership. They have every tool you can imagine. Water jet cutters, laser cutters, 3D printers, anything you can think of that you would build something with. Sewing machines, just anything. They have it, and it's available for you to use with your membership. What they also have is they have at least $20,000 worth of software on each machine. So anything you'd ever need to create, the full Adobe suite, the full Autodesk suite, design suite, is on there to use. And we teach classes on all those things so we can help you kind of get up to snuff on it. One thing that TechShop does that I think is really innovative and maybe something to take away is in college, you tend to get about 3 to 7 hours of instruction and then 10 weeks of personal practice. And that's what you pay for. At TechShop, we just give you the 3 hours of instruction and say, go for it. And then we have people around to kind of help you with that next stage of development. So there's a TechShop down the street, and if you've never gone, that's my pitch. It's good to go. I give a great tour. And it's on 5th and Howard. So right between 5th and 6th. It's a beautiful building. There's parking there. Only $10 a day. Right, and I just want to share a couple things that were built at TechShop. So some of the things that we're seeing out of the maker movement and people just being, people being cool, crazy people. Andy Philo is a top-end industrial designer. If you think back to some of the coolest things built in the late 80s, early 90s, chances are Andy had a hand in it. And so he got a little bit sick of that and then switched over to, I want to build a jetpack. And we said, okay. So he did it. He got a sponsorship from, I think their name's GoFast. They're like an energy drink company. And he figured out how to do it, and they had a pilot, and the pilot came, and they said, we're going to fly over Diablo Canyon. And the pilot said, great. And they launched this thing, and it's really cool because it's all chemicals, so it's not hot. And they went almost over the entire canyon and dropped a little too soon, ran out of fuel, and broke a leg. So the important part of this is that he didn't die. Yeah. So what we decided to do instead of keep going through pilots is Andy decided to 3D print an entire simulator suit because it's cheap and free, and he did it on an up printer, which is similar to the MakerBot, if you've seen those. We'll talk about that in a second. But he printed an entire simulation suit that you could wear and then wrote a program so that it seemed like flying. Because when you fly those, it's not like a motorcycle or anything else. It's a very different feeling to it. And you're actually flying upright the entire time. So he's doing great, and they're at a minute and a half now of flight time. So soon, flying to work.
Is he working on getting the jetpack better? And because
Yes.
I remember a long time ago, jetpack.
Yeah, I want my rocket suit. Yeah, totally.
I'm just wanting one. So.
Yeah, no, they're working on it, and his whole thing is right now they're paying for all that with basically sponsorships. So they fly into the opening of Glee or whatever TV show thing you watch. But
Take a leap and say, in your opinion, given what you know, when they'll be commercially viable like a car.
quite seriously, 5 to 7 years. I know a guy in LA that's doing flying motorcycles, and they're pretty close to production. So I'm saying 5 to 7 years, you can actually find these on the market. And it's, don't quote me, but don't come find me. But, cool. Another cool story. So this is Ken Hawthorne. Ken Hawthorne is a member at TechShop San Jose. He has broken the land speed record on a motorcycle. Why is that cool? It's electric. He was one of the first electric motorcycle builders out there, and he built the whole thing in our shop just because he had access to tools, had never built anything beforehand, developed a team, and went for it. Another kind of cool but different success story is Patrick Buckley. I got to work with Patrick, so that was kind of a cool one for me. He came into TechShop Menlo Park. We taught him Inventor, which is kind of like a SolidWorks type thing. It's engineering software. We taught him in 3 hours and helped him learn a little bit of CNC, how to use a thing called a ShopBot, which is basically a router mill. And we made the first dodo case. And right now, you know, Patrick saved a book company in Dogpatch, and President Obama just bought one. So he's doing okay. Patrick's doing okay.
No, I don't know what dodo case is.
So dodo case, actually, I have one. Could you just reach in that bag and grab the black case? Oh no, I'm not strapped in. Haha! I thought it was on a leash. So it's a simple, silly device that holds an iPad. I cannot tell you how many people come into TechShop every day and say, I want to make a device that holds an iPad. Sit back, because it's so cool. And it's like, yeah, that's great. But his actually went, and it's beautiful, and they work really well. I've had this for 2 years, and yeah, I just think it's a nice story because there was a book company in Dogpatch that was going to go out of business. This actually saved the whole bookbinding company over there. Created.
Making them the way they're beautiful.
Yeah, because they're all hand bound and then CNC'd out machinery. So it's a really cool thing, and it's local. So you know, I'll give my SF Made plug as well. Shop local. Cool. So, and then this is my transferring point is. Does anybody know this guy? Yeah. James. He was cool. He came in. Everyone thinks that thing was, you know, somebody had big influence in it and a lot of money in it. He came in with almost nothing. We taught him how to 3D print. We had an old, really bad 3D printer at that point, and that was only 3 years ago. They've come a long way since then, and we 3D printed his first prototypes for him, and now Square, you know. So that's a perfect setup for talking about 3D printing and what it really can do for us, as opposed to, there's lots of really cool things in that table, but a lot of them are on the tchotchke level of, look at this thing, I made it, and it sits here. And this one's like that one, but it's different, and it sits there. And this one's made out of a different material, but it sits right there. But this one's a lamp. You know, and that's kind of like where 3D printing, I think a lot of people think of it like that, and it's really made for prototyping. It's really made for people that want to take their idea to the next level and be able to be physical without learning 5 years of real craft to kind of pull something like that off. So, 3D printing. Here's where it began, with 2D printing. So when you ask me what's the next stage of 3D printing, what am I going to say? 4D printing. It's coming. Be ready. It's not coming. It might be coming. We don't know. You'll settle for the jetpack. So yeah, 2D printing years ago, you know, kind of difficult. Took a lot of big machinery. Had to be in a special place. It became, you know, an at-home thing. Years of innovation developed. Now we can do it. We have a web browser. Every program pretty much goes to a 2D printer, and that's sort of what we're looking at right now. This is currently the system of getting a file from a computer to a 3D printer. You save an STL file. What's STL? Stereolithography. I thought you knew this stuff.
Oh, I know that.
Okay, good. Say that. Don't mess with me, man. Okay, yeah, so it's stereolithography. What that really means is absolutely nothing to you. It's basically a file format that stitches, it makes polygons on the surface of something. If it's a good program, it'll make it watertight, so when you do a 3D print, it doesn't make a block, and it makes your object. But right now, that stuff's getting easier and easier. So, currently on the market, we have these two types of printers. We have dozens of each type, but these are kind of like the two in the realm. You have the professional grade, the Object Connects 500, which is over on the your upper right, and that thing cost $500,000, which is fantastic. I have 7 of them, which is fantastic for me. But to get that out, we need services, and then it's a very finicky machine. The material is very expensive, but you get a good print every time, and you get things back that would save you a lot of money as opposed to sending overseas to get a mold made, to get something injection molded, and then brought back.
What's the end material?
The end material on those is proprietary to Objet. It's ABS-like, or it's they have a bunch of things that are like other materials, but it comes in a goo and a cartridge, and it's the easiest machine in the world. You just actually plug the cartridge in, it prints. It printed most of the things on the table, like the black rubber monster, the crystal ball hand. That's typically things that come out of an Objet. Below are what we're calling consumer grade printers. So a lot of people have heard of these. Does anybody own a consumer grade printer? MakerBot? No? Come on, people, get with today. So on the left, on the bottom, is Type A Machines. They're a company out of TechShop San Francisco. They make pretty awesome prints. So like the cup on the table, that green thing is actually a screw thing. If you turn it, apparently it falls apart, which is what it's supposed to do. And on the other side is there you go, is a MakerBot. MakerBot is by far the most widely known of the commercial grade 3D printers. You can do pretty much anything with a MakerBot right now. Some of them have support material. Some of them make my watch, which is great.
Is that the best one around that's out there now at this point, at this level?
Of course you ask me that. On camera.
Just an opinion on that.
So my opinion is this. If you're looking for a 3D printer for your home and you want something that is part of a company that has a lot of support, they're gaining a lot of momentum, MakerBot is a really nice way to go. If you want something that's local, that prints a little bit bigger, that you'd like to work on a little bit and have a little bit of tinkering involved with it, maybe manipulate it, a Type A is another perfect way to go. So it's kind of buying an old car because you love working on cars, or buying a new car just because you want the thing to drive. And there's, that makes them sound bad, but there's a lot of people in the makerspace that really love that. And I'm one of them. I could spend days fooling around with a 3D printer, and they're really simple. It basically is a hot glue gun, and the material that goes into that is either called ABS or PLA. PLA is what they make Legos out of, so that's easy to remember. And it takes a spool and it puts it through a heated head, and then it builds up. And if you look at those over there, either later or you can pass them around if you want, it kind of builds it up layer by layer like that. The ones on the top work very similar. The Objet actually spreads out a very, very thin sheet of goo and then comes back on this side with ultraviolet light, hardening the goo, and then builds up layer by layer there. So little, though, that you would never be able to see layer by layer on it. Cool. So these are things we typically build with the Objet. We can do brushes, we can do wheels, we can do things inside of things, which is awesome for medical research. And it really does help on the education front to show doctors and other people, what a bone looks like inside of a foot. Yes? We are printing 2 materials at once. So if you want to pass around the ball with the hand in it, the orb, trust me, we can print more of these things. I've bounced that thing on the floor a couple times. It's totally fine. But that's a good example of that. That's called a Boolean operation. I can talk about that a little bit. But it's 2 different materials. So one's clear and one's called a Velo White, which is, again, proprietary to Objet. You're limited to 2 on the Objet, and I'm going to get to it in just a second, but I'm going to pass around these, which are done by a service, which you have a bunch of choices. I'm not going to count them right now. Cool. So other things that we've seen on Objets, a lot of prototyping, a lot of engineered prototyping. If you want to build an engine or something, an Objet's a really nice way to go to see what it's going to look like and make sure everything's going to go together before you go machine heavy aluminum or steel. Architectural models, we're working with a lot of companies right now to build architectural models. It prints really easily. The average cost of a model out of an Objet? Yeah. So. $2 a gram. How's that? Yeah, it's not bad until you get really big, and then what I would say to you is this is the difference between rapid prototyping and 3D printing. 3D printing is awesome for little things and little small models, unless you want to pay a lot of money. And from there, you want to go into something like rapid prototyping, like those big cardboard models, or the Trojan horse. You would not want to 3D print a 12-foot tall Trojan horse. You might want to print a 12-foot tall, but don't do it. You want to use something like laser cutter. Yep. Yeah. Yeah, so when we send stuff, I'll talk about our South African experience in just a second, but and on the high-end machines, it's $2 a gram, which is basically kind of a blanket cost, and it ends up being between $100 and $300 for a mid-sized part. On the low-cost machines, you pay $50 a spool, which you then get 75 prints out of. Prints end up being around, I don't know, $2, something like that for most of the prints on the table, not even that. So difference in quality, but one of the cool trends we're seeing is the high-end machines are becoming lower in cost and faster to print, and the lower-end machines are becoming a little bit higher in cost, so and better quality prints. So I think within the next 3 years, we're going to see somebody come out with that one that just clicks with everybody and goes, it prints fast, it does what I want it to, and it does a range of things that are, incredibly awesome.
Jesse?
Yes.
Can you explain the point you were just making about creating small objects versus the Trojan horse? Is that a
Sure.
difference between outputs or different types of
Yeah, so if you want to do something at any real scale, you really don't want to 3D print it. And it's funny I'm saying that because I'm about to show you something gigantic that we 3D printed, but you should. It's probably not best practice.
Yeah.
You'd want to use, we have a product out called 12-3D Make, which slices 12-3D Make. And what that does is it slices large models up into a variety of different ways to make them very big, very fast, which either, CNC router or laser cutter or water jet, whatever CNC, computer numeric controlled machine. Cool. Other things we're seeing with the object real quick is a lot of dental work, a lot of people putting inserts into things like bone cavities. There's a great example of that. And of course, the giant thing that we shouldn't have printed, but we did because it was cool. We 3D printed, 3 years ago, we 3D printed a full-size chopper. If you're ever around on a Wednesday afternoon, such as tomorrow, you can go down to the Autodesk gallery from 12 to 5. It's in there, as well as all our 3D prints, so there's more stuff than I brought tonight. The Autodesk gallery is at 1 Market Street, on the 2nd floor. I'm full of plugs. So, this is Gonzalo Martinez on a 3D printed motorcycle. That was Gonzalo's product. He is by far a really nice mentor to me, but also he was in the forefront of the 3D printing movement and really followed it along. So he's sitting on it there. It's full size. It hangs in the gallery. It does not turn on. There's no electrical components. But man, is it fun to sit on. It's kind of a cool thing. So there's another shot of it.
And how long before this lovely thing, there's a version of it that actually works and you can ride it around the block?
I would say, with at the rate we're doubling by, if you use like Ray Kurzweil's, doubling it's I would say 5 years. Because we're already printing conductive material, we're already printing biomaterial. I mean, I don't know. I think it's going to be...
Are you talking about biomaterial inside the human body?
Yes, but let me get to that in a second because it's completely different. All right, cool. So the next thing Gonzalo did after that was made a giant twin turbine engine that actually worked. Worked as in functioned, as in turned. We could make sure all the tolerances were there, actually moved around, whereas the bike was more of a static object. Not all the pistons moved. Not worked as in flew, but there are a lot of people experimenting with that. Open Rove, which is an underwater robot, they use 3D printed propellers on their machine as well.
seems like there's a certain material that you use for some simple models.
Totally.
But then,
Yeah, as we talk about in just a second, we'll get to that. And it really does run a very large gamut right now.
Jesse, did you say that you could actually see all this stuff in Autodesk?
Yeah, if you go down to the gallery on tomorrow from 12 to 5, it's all in there. The motor's not in there, but the bike is. And some of these are in there. Man, she's going to kill me. I just forgot her name. I believe it's Amanda. She works at Instructables. She is responsible for the world's first 3D printed record that we finished 2 weeks ago. And it sounds okay. What's really amazing is that she figured out the code to take MP3s and turn them into a digital format so that you could print a record from it, which is just amazing. And it does play music, and it's a little muffled, and but what's cool is, we're 3D printing records like crazy. I mean, you can see the stack of them. What was the first 3D printed record? Is that what you wanted to know?
No, what's RIA have to say about that?
So that's something we should get to too, is rights, which we try not to talk about. This is going to be, if anyone's seen the article on this, this is going to be the first 3D printed home, apparently. We'll see how it goes. I believe it's in the East Bay. I believe so. Yeah. When they say 3D printed, I think it's a little bit different than what we're talking about with 3D printed. I think it's more CNC manufactured with concrete using a giant CNC XYZ platform. Does everybody know what when they're talking about when I say? Okay, so CNC is computer numeric controlled, and what that basically means is in all life there are platforms. And basically there is an X, which is there's an XY. There's a XY is basically this surface. YX is, or YZ is this surface, and XZ is this surface, right? So these are the three planes on which everything is created in a CAD, and as well as CNC. So what CNC is basically anything that operates within an arm that travels along those axes, and then creates an operation based on that. So if it's a CNC printer, like the 3D printers are all CNC, that has a moving head on it that moves around and then melts the plastic as it moves around. And that's how we're getting CNC prints. And if we're doing something else like milling, which is basically that same mechanism, but instead on the head is a bit that spins very, very fast and hurts very, very much when you touch it when you shouldn't. But it also cuts through a bunch of stuff and makes flat pack furniture and all these things possible. Same with laser cutters, same with almost any machine that you'll find in TechShop right now. Tormax, everything else. I did not, but I watched someone. And it was not as funny as I thought it was going to be. So how do you get 3D prints if you're you? And you don't have access to a tech shop and you want to experiment with this? There is a company called Chickways, and Duan happens to be a nice friend of mine and sent me these cool samples, so I'm going to throw them and someone's going to catch them. Excellent. And this one's made of metal, so be careful with it. We'll go in the front and pass it around. So what I'm handing around right now are all the materials that Shapeways currently prints, which happens to be all the materials that the other two print too. They're just different types of services. So what's going around is you'll see samples of bronze. You'll see examples of something called aluminide, which is very similar to aluminum. You'll see examples of ceramic. So ceramic is the first really food-safe 3D print. PLA, which is a corn-based plastic that I mentioned earlier, is technically safe because it's a corn-based plastic, but the powers that be say, please don't drink out of this. It's melted plastic, people. Yeah. So that's kind of on those areas of materials. And everything else that you can see going around and that we have over here, you can print in rubber. We can print in just about anything right now. Name something.
Wood.
Can't print in wood. Actually, people are doing it, but what they're doing is they're creating dust with the wood, and then it's a process called laser sintering, where they're taking that wood and they're putting a laser on the top of it, and it's actually burning it together, fused with glue, and that's coming out in a wood-type shape.
Then what's your fabric?
Hold on with the fabric, and
M4 is doing laser
Yes, layered paper, which you could count as wood. Yeah, I have some rumors about Encore, but I can't say them out loud right now. But it is a really fascinating printer, and if you want to watch an amazing YouTube video, check that one out because it's full color.
What is the video?
If you check on MCore for just do MCore 3D printer, it'll show up.
MCOR.
Yeah, that's it. Yeah. Yep. So other things. Metal. So what you see going around is steel, aluminum, bronze, and those work the same way. There's two ways to do metal. One of them is having that vat of kind of crazy dusty stuff, and we shoot something really high temperature into it, and we come out with metal. So it basically melts it. Yeah. Yep. Exactly. And the other way that it happens is we print something in something like wax, and then we cast it with metal, which is a second post process. And we actually can do that the same way with ceramic as well. But there is a ceramic printer, but that's a very different process. Yeah.
So for artists that are working in 3 dimensions, is it possible to take something that is 3D printed, like in a megabyte home, to like the Crucible?
Totally. There's a bunch of artists that do that, and you can cast out of PLA because it will melt out. The results are a little varied depending on how the PLA reacts with your sandcast, but it can work. The other way to do it is to send out for a wax print and pray that the mailman has gentle hands, or the mail person, sorry. Wax prints, you have to look for, they're special, so you have to do a Google search for wax prints. There's a couple people around that do them. It's kind of a different deal. I think a lot of these companies got away from it because it was like, yeah, we keep sending them out, and people are angry. I don't understand. What's cool about Shapeways, it's a little bit on Materialize and a little bit on Sculpteo to do this too, but Shapeways is sort of the Etsy of 3D printing. So if you want to get involved with jewelry making, or if you want to get involved with something 3D printing as a business, what's awesome about Shapeways is you can actually open up a store on their website and sell your 3D prints. And that doesn't mean you have to keep the inventory. It's just as soon as people order them, they print it and they send it out for you. It's a perfect formula to make a really nice small cottage industry. And so this artist over here makes these prints, and they're fully movable and just absolutely beautiful. Cool. So that's services. Where do you get the models to 3D print with? Let's start off the easy way. Let's steal them. So stealing things is great, except for it's not really stealing anymore. We call it sharing, and it's fantastic. And so the places I recommend to share models and to get models to download, to experiment with, or to alter and make your own are, I should say 123D first because I work for Autodesk. And so that's the one in the middle, and that's a gallery full of hundreds of models that are available to download and open up in the program that I'm about to show you. On top is Thingiverse, and that's MakerBot's own, started with a RepRap society, which is a society of people that were early adapters to 3D printing. You don't really need to know about the RepRap people. They're like a weird, different, you'll figure it out. Anyway, and they started Thingiverse, which it was kind of a sharing thing of, hey, I 3D printed this, hey, I 3D printed that. And then they mix them together, and all of a sudden there's a Pixar lamp on there that actually moves around. And we can get to your question that I know is burning in your head. So far, on record, no one cares about that. Someday, soon, Napster 2 will happen, and someone will come down from on high and say, could you please stop printing, oh, Darth Vader Lego men like I do every day. You know, like, it's going to happen, and we're going to deal with it when that comes. But right now, I think the way businesses are looking at that, you know, companies such as Hasbro or Lego, I think they're looking at it in a way to say, well, why don't we just sell the 3D model? You know, why don't we just figure out a way to make that ours and, you know, work around it as opposed to going in sue happy with a bunch of people that are hopefully changing the economy, you know, and creating different types of entrepreneurship. Cool. Oh, and the third one in there was GrabCAD, and that's a different animal altogether. So that was it on the slideshow, and I was just going to show you real quick what the software looks like. So let's say, was that it on the slideshow? That was not it on the slideshow. Cool. So if you didn't want to steal your model and you wanted to start somewhere else, there it is. What's the second easiest way to do it? Take pictures, right? So right now we have an app out called 123D Catch, where you can basically use your iPhone, iPad, Android, whatever you want to do. Android's not out yet, but probably coming soon, I would imagine. We're a big company, we do those things. And you basically take a bunch of photos, a series of photos of anything. So you can see the Buddha up there, that's on the table here. And that's Christian, he's our product manager for that, and his nephew. But you can walk around that object, and you should do it right after this talk. We'll walk around and do somebody's head. And with 20 photos, it stitches them together, and you end up with something that you can 3D print, which, you know, kind of in the tchotchke vein, we can make a Pez head, or, you know, doorknobs, or whatever else you want to put your head on. That seems to be the first thing people always go to. But now we're starting to see people really jump into it, do motorcycle engines, do, you know, some really fun stuff, or interesting linkages.
Is there a way to manipulate that file?
Yes, there is. So right now, currently, 123D Catch, you can manipulate your file online. If you go to 123app.com and you go to the Catch section, pretty much all of these things I'm going to show you in just a second also have a web-based platform, and the web-based platform is pretty powerful. So on Catch, you can actually go in and you can change things up. We also have another free program that we don't talk about very much, but you can download it. It's called Mesh Mixer. So write that down if you're into converting STLs into, or making yourself into a 5-headed monster, or like me, have a coffee cup with my head on it. Mesh Mixer. And what that is you can take the mesh that you created in Catch or any other STL that you shared from Thingiverse and bring those in and put them together. So if you made something in engineering software, such as a coffee cup, and you took photos of your head with Catch, you could then put them together in an STL thing with Mesh Mixer. It's through Autodesk, yes. It's acquired through Autodesk. Cool. So that's Catch. We'll talk a little bit more about that, but it's pretty fascinating. So these are the types of things we're doing with this technology. We worked with Louis Leakey and the Leakey Foundation as they're doing things in Africa, and they're out in the field and they're digging up things that are extremely fragile, and we really don't want to ship them. We're having them take photos of it, send us the file, we're 3D printing it, sending it to the Smithsonian, sending it back to the Leakey Foundation, so that they can have something they can handle and run tests off. Yeah, it's nice.
And you can get that kind of detail.
You can get close to that kind of detail with 20 photos. That's our consumer app for that, and it's totally free. And if with a little bit of cleanup, you can definitely get everything you need from it. I mean, we've never had too many problems. I will warn you, if you're going to go download it right now, the first time you use it, you're going to be horrible at it. And you'll get a varied result. Keep trying. The second or third time, it's just like any software package. You'll go, I get it now. And then you can do almost anything. It took me a while, and I was like, this thing's broken. And then I went to the Yoda sculpture over at Lucas and borrowed Yoda. I know, I keep putting myself in a hole tonight. Jail. Yeah. Sorry. So it's 20 to 40, and what you want to do, and we can do a live demo of this. I can use it on my iPad, and we can do somebody's head to kind of show you that. And just give me 1 second to walk through some of the other stuff. But yes, so TechShop has what's called a Next Engine scanner, which is a laser-ish scanner. It works on ultraviolet light. It works pretty well, but I'm finding the results from our app are actually just as good as that Next Engine scanner. The thing you get with the Next Engine scanner, which is nice, is if you're into engineering software, you can take that out, and when it brings it into something like Inventor or SolidWorks, it puts a design tree of the features it thinks that you would have made to create that, which is... sorry, let me back up.
Jargon.
Yes, I should put a quarter draw out for this stuff. A design tree is the tree on the side of high-end CAD programs that shows you basically your history of everything that you did. So if you had to extrude something to get somewhere else, it shows that process. So what it does is, so I'm taking a picture of this box, I put it in there, and it says, you must have done X, Y, Z. Or this is how I'd go about building it. It's kind of like the Surrey of CAD. This is Christian at the Asian Arts Museum. So what we've been doing, another thing we've been doing with that technology is we will go into art museums. We went to the Met, and we will steal art and then reproduce it on site using, we usually partner with MakerBot or somebody, recreate it on site and set it around so that people can actually physically hold this stuff. Some of it's really interesting, but museums, for some people, are a little bit hands-off. Me coming from the exploratorium, kills me. But yeah, so we're trying to make that a little bit more hands-on and try to change how your experience of a museum, and how do you get more involved with a model. Cool, so this is the other way to create a model. This is by far when you're really getting into it and you need that custom thing and you want to make the next big device and you don't want to spend a bunch of money at school. Go to this. This is called 123D Design. It's another free app that we released, and I think it's really, from using a variety of CAD programs, it's by far the easiest, and I'm about to show you why. It's a really nice way to get started, nice way to get started in 3D printing as well, so you can create pretty dynamic things in it for free. And when you complain about it, remember that it's free. And you were too cheap to pay for the good stuff. Yeah. What does it suck at building? It doesn't suck at building anything. What it doesn't do well is, like, if you're interested in something that's moving engine parts and trying to get that stuff all dialed in, not the program for you. If you're interested in building a really cool new set of headphones that are very organic shaped, this is your program. If you're interested in, making cool models or robots or just getting into CAD, this is a really easy stepping stone to get into that. After that, I would recommend moving into, we have some new products coming out called Fusion 360, which is kind of the next iteration of this, or Inventor, or I won't say our competitors' names on a camera. Yeah. Cool, and these are a couple other things that we've made with that. Probably should take that off the slide reel, but there's the clear Darth Vader, the envy of most of my friends, and I do print a bunch of those out. And next is something that someone did, basic iPhone cases. So customizing iPhone cases is a big deal right now, and everybody wants to do it. And it's not a bad way to get into this stuff. I mean, it's something that everybody uses. It's a really standard measurement that you can download from the Apple site, and then you can add on whatever you need. Other things that are embedded in the program is there's robots embedded in the program, there's trains embedded in the program, I'll show you in a second. And on the upper right this is what I think 3D printing is probably the most useful, could be the most useful for now, is when you're an inventor and you just need something to stick this to this. Not that you would ever stick those two things together, but whatever. And they don't make that plastic part for you, and you don't want to glue it because it's permanent, and you just need to figure out how to get something to something else. 3D printing is perfect for that. And CAD modeling with 123D Design is perfect for that. So you can build things to spec that you need. I saw this awesome girl today at TechShop who built these awesome light up helmets and just had 3D printed the hinges because there's no other way to do that. I mean, that's where I think we are with it right now. I even know a couple people that are doing production runs. They're starting to do production runs with 3D printing using 123D Design, and then they're you laugh. It's another iPad device, but it hooks it to a tripod. It's a really cool device, but he's not going to sell thousands of them. He's going to sell 50 to 100 of them. And he's retired, and that's just what he wants to do. What is the item?
That you're referring to?
It's not on the market yet, but it's a device that it holds your iPad or your iPhone onto a tripod. Damn it! Damn you, Apple. Yeah, and then you can screw it in there, it's a nice way to go about it. Cool. So with that in mind, let's see some cool software. When I say production runs, I mean light production runs. So if you want to go to Shapeways and sell jewelry or one-offs of something that you want to do short runs of, talking in the hundreds, 3D printing is an excellent way to go right now. In years to come, who knows? I mean, that could be the way to go for all manufacturing. Probably not, but could be.
So there's companies that'll, you send them a file and you say I have 200 of these and they'll do it for you.
Yep.
Or Shapeways is doing pretty
Shapeways does that. Yep. And they do it by demand. Yep. There, I mean, it's like anything else, and there's always a little bit of post if you want it. So like that specific model, I think it's made of ABS. If it's made of ABS, you can actually take nail polish remover of all things and put a little bit on it with some sandpaper, and it'll become very smooth. The other ones that you see that were made on the object, you can take model paint if you want to do them in full color and really get into it and do some modeling, which is a nice way to do like character development and creature development. Yeah. I 3D printed my Halloween mask last year, which I never wore, but I still did it. And I used the rubbery material, and it came out great. What I did is I went to the New York Public Library, took a catch of the lion head on the outside, and then made that into my mask. It's cool. But yeah, there was no additional sanding. I don't know, just if you want to get into personal stuff, Halloween, I just wasn't into it this year. I don't know why. Yeah. I'm not the true San Franciscan. I can't handle this many dress-up holidays. It drives me nuts. I'm from New York. Sort of. Yeah, that's right. Upstate. Yeah. Binghamton, Rochester. Yeah. Yeah, you're like 10 minutes out of the city, right? Queens. I'm from Queens. Cool. So this is the interface for 123 Design on the desktop, and this is how easy it is to build stuff. So there's a couple things in here that's cool. One is you sign in, so all of your storage, if you would like it to be, is on the cloud. That's not in a cloud. It's a space in cyberspace that we store in Ohio, I believe, or in the server rooms up there. But they come back to you, and you can use your files that way. What's also nice about that is you can do the sharing thing, and when you make something, you can put that into the overall online gallery and let other people take it and manipulate it and do what they want, which is awesome when you see the rocking chair that you built on 300 different people's sites, and you're kind of like, that's cool. I'm glad people really enjoyed that and could make something useful out of it. Because for me, it was just an exercise in rocking chairs. Cool. So basically, I went up to here. This is where my primitives are. I chose a glossy table to put my mouse on. And then I just chose a box. And then basically, I'm just pulling it around. On the bottom of the screen here, you can see where the length, width, and height are. So if I put those down, and let's say everything with this too, if people that are into CAD, everybody's used to multiple fingers on the mouse and doing this thing to try to move things around. This is all 3-button mouse. That's it. So we developed it so that you could do it on the iPad as well, so that you didn't need to know, Control, Shift, all those other things. So this is just right-click on the mouse to turn things around. There's also this cool view cube up here if you want to do views of things. But okay, so what makes this program different is that there's a box way out there, and that's why I'm having issues. Okay, I'm going to use this.
Which program is this called?
This is called 123 Design. So if I select this and then select this face, if I hover over this little starburst menu or whatever you want to call those, I can hit tweak, and I can just grab this and shift it. As opposed to, some of the higher-end engineering software, you still can't do that, and it's a little bit of a pain. I can also grab an edge and tweak the edge. Or simply, press and pull.
Can you ever import like a sketch to build up from?
Yeah, so you can actually start from a sketch in this. And the way you would import a sketch in this specific program is you would save it as a JPEG and then try to bring that in and build on top of it. As opposed to traditionally, bringing in different sketches.
Just basically expanding that z-axis then?
Yep, that's it. So if I wanted to start from a sketch, I can go up here. There's different things already in there. Square, ellipse, polygons. There's polylines. There's splines, which engineers hate because they're splineless. Yeah, it's getting weaker with time. It's time to retire that joke. So rectangle, if I choose one corner, move it out, there's my next corner. And then put a circle on this thing. So what I like about this program is when I do my extrude, I can choose the overlays. I don't need to go in and trim things. So if I make a very dynamic shape and just have everything overlaid, I can go in, choose it, move it up. And what's even cooler about that is I can still use that sketch. So if anybody is used to CAD programs, you can only use the sketch once usually, and once it's used for a feature, which is an extrude, it's done. And it sits in there and it holds on to that. But with this program, you can reuse that sketch as many times as you want, so you can go in multiple directions. It's very, very quick to build something up.
What's the possibility of texture mapping so that you can actually print out with a certain texture?
So that's what I want too, and it's not out yet. It's just simply not for consumer-end software. I think it's something that we all talked about and said, if I'm going to build this thing, I would like to have it on a wood grain or something. So yeah, it's definitely something we're looking into. And let me just start a new file here. That's interesting. You cannot. Sorry. You have to make your own. But you can import STLs from any program you want. It takes STLs. You just have to upload them to the gallery first, and they can download them. So it also comes with these for people that like to build things. It comes with these kits. And it comes with a bunch of kits already in here. So there's an anatomy kit, a charm bracelet, a playground, a model house, a motorcycle. Let's do a robot. So and under the robot is these pre-programmed. So if I bring in the head, oops, boom, and then I can alter the head however I want it, like I showed before. So this, I can press and pull, or tweak, or do whatever, and move things around. Customizing it to make it mine. And then there's bodies in here as well that just snap to it. And I won't get too far into this, but then there's arms and legs, so you can really customize your own robot and then send it straight out to a 3D print, or you can send it to a service that does 3D prints, or you can have your own STL file and take it into something like Make. Yes?
Do you guys do any outreach for like junior high, high school?
Yes.
Are there any lesson plans?
We have a full education department that have lessons plans, and they're developing them on this software, which is sort of a new software, so we're still working on it. And we also, through Instructables, have some links there as well. If you want to see me after, I can give you a card and we can dice that up. So let's open from my project. So these are things that I've already built, but it gives you a sense of what the gallery has in it. So this is the type of stuff that I feel like this program is perfect for, but other people find different uses for it, and I think that's wonderful too. Is you can do full color in here. So we can really get into it, and then you can 3D print these, and if you build it right, when you 3D print, we can actually remove this space, so you can put your speakers in there. 0 to headphone, and I think this took 25 minutes, if that. Which, kind of our stance on that side of it is, now that you can 3D print, and now that you can design super fast, it does take you back into design philosophy and really thinking about what you're making. Which is something the maker movement so far has not really excelled at, because it is a lot of like, ain't it cool so far, and I think we're just about turning that leaf of going, yeah, but this is really cool because I'm pulling in stuff, solar power from this to charge my headlamp that I built with my 3D printer, and it's really starting to move in that direction. So if I wanted to take this and make this, I would basically just come down here, and let's say if I wanted to do an STL, I can send it to, it just says send to, I can send it to 3D print, or I can actually, I'm not going to show this because it's a little high end, but we can send it to a CNC utility like a ShopBot, and it actually writes the G-code online, so you no longer have to be CNC expert to do this. But I'm going to send it to Make. I'm going to fake send it to Make because I already opened it in there and it takes about 5 minutes. So here it is in Make. And what Make does are those cool cardboard things you saw over there. So if I select a technique, I can do stacked slices, bottom, and on the side over here, those are all my laser cut files. They are numbered so that I know which ones go together, and they also have little pinholes in them. So if you really want to get technical about stacking cardboard, get a life. But really, you can put those things together if you want to. And we can also change the settings, so you can change your sheet size. So if your laser is 24 by 36, you can change it into that. Or if you want to use a piece of steel, or whatever else, plywood, you can put your custom settings into. We can also change the size of it. We can change the slice direction just by grabbing this thing. Boom. Yeah, not bad for free. I'm actually going to try to build these out of like a foam, because you can, basically do whatever with these things. Yeah, and the coolest thing about it is there's this modify form tab, and there's 3 things in here, so you can hollow something. So let's say I made a cube and I wanted to have a desk, and I needed it hollow on the inside. I can actually say hollow. It'll hollow out the cube to my variance, and then tell me how to create it from there. It can do thicken, which is what we need to talk about, because if I thicken this, you'll see these little hairs come off it. That's how far it's thickening. If I thicken it just by a little bit, and I apply it, it's going to look a little bit bulkier, but what does that give me? That gives me room to sand it down. So if I want to rapid prototype something and I want to go laser cut this out of whatever, wood, if you want, craft ply, that gives me a little bit of room to sand it down and bring it back to its original shape. Real sturdy. Pick something up. Yeah. Sturdy for this stuff, it's all on how you build it, right? So if
So you're saying like for this way, you kind of like make it a little bigger, it should be more.
it'll be a little bit more rigid. Looking at this though, you got to think about design still. If you're going to put this on over your head, and you might have to pull it a little bit. All your glue joints are this way. So if you're pulling it that way, chances are it might break. Because that's the weak link, right? So you'd want to go the other way to make it, use the cardboard, use the, what's that word? Something, tensile strength of the cardboard. Triangles. Cool things. Yeah, so that's what you would do with those. And you can also, instead of stacked slices, we can do, this is going to look funny, but you can interlock stuff as well. So you can do what's called waffling. That's what we build really big structures out of very quickly. If anybody went to Red Bull Flutog this year? No one? Really? Come on. Okay, so there was an egg there that a girl jumped out of. It was all made because they could do this very quickly, CNC with plywood, and put it up, wrap it like an egg. And there's a bunch of other options in here as well. So you have interslack, there's curve, there's radius, and there's this thing called folded panels. Folded panels are what we made the Trojan horse out of. And come on back. Basically what that does is you can see the puzzle pieces over here. So it's origami. It's just laying it out flat. It actually puts the fold marks in it. So if you took it to a water jet, it would actually cut out those little fold marks, and you could bend it by hand. And this is called folded panels. And it's awesome. And hopefully, I can't talk about that. Never mind. But it's going to get better. I'm just going to say that. So when you see things like the Trojan horse last year, we were able to make that scale within a week. I laser cut it in a day, and then it took a team of 5 of us and 3 six-packs of beers to get halfway done, and then come back the next day and build it.
Your favorite thing that you've done?
No, the car, I have a lot in the car, a lot of emotional investment in the car. As my wife can tell you, I have a lot of emotional investment. Currently, we built guitars this way. So I designed a guitar, it's an old Gibson style acoustic, and we stack laminated the cardboard, so we did the stacked slicing of it, and then we draped carbon fiber over it, and made wooden faces, and they're absolutely beautiful, and mine's almost done. And if anybody's interested, on Saturday night, what we did for this is we took a team of 13 people that had never built anything before, and we said, come in, you can custom design your guitar, we'll laser cut it, we'll help you walk through this process. 6 days, 36 hours worth of instruction, and in the end, we have at least 7 to probably 12 people that are going to have a finished guitar, handmade, carbon fiber. On the market, we're talking like $3,000, but you know, at TechShop, probably did it for $700, and they all have to play a song. So it's like, congratulations on making this beautiful piece of thing. Now let's see you suck. Yeah. So if anybody wants Saturday night at TechShop, we're going to do that. I think it kicks off at 7. This coming Saturday at TechShop at 5th and Howard. You can come watch, and you can see all the instruments that people made. They really made some beautiful, just strange variances of the guitar, and they're absolutely gorgeous. 7, I believe. If you call TechShop front desk, they'll tell you. But it should be a fun little event, and plus you can kind of see the shop and hang out. Cool. So the last thing I want to talk about, and I know our time is getting really close to up, it's just this last thing about community. It's so important in this group and in this new culture we're developing to be able to share and to have community. So a place like this is just perfect for this stuff. Places like TechShop, maker spaces like Noisebridge. Go to those places. If you're into building or if you think you want to try it, just go try it. It is a life-changing thing. The first time you learn how to weld metal, the first time you learn how to cut wood or use a laser cutter, it really does kind of change your life and takes you into a different realm of, you know, possibilities. So yeah, we're right at the end of even question time because we kind of took them in between. But yes. At TechShop, we do not have a kids program. What it is 12 through 18, you are allowed to be there with a guardian. So 2 people in the guitar class actually were under the age of 18 with their father. They each build a guitar. How cool is that when you're 12? And the cool thing there was they got to skip school last Friday. Because it's more important to build stuff. And then at over 18, you're totally fine until you're about, well, our oldest member was 86. He was a master machinist, and he came in to finish his model railroad. That's to scale it. Yeah, he was a cool guy. Yeah, so I want to give people time to mingle, but I also want to answer questions. You good? Okay.
What does one need to do to be able to attend the Saturday event?
Just go to TechShop. We're going to have an event sign up, so they'll just give you a little wristband, and you'll wear that and walk upstairs with a name tag. You'll drink some probably awful beer because the guy that's buying it doesn't drink, and you know, just kind of eat the free popcorn and drink the coffee. And
what's the exact address?
911 Howard Street, I think. I'm only there every day. I should probably know. Just go. Yeah, if you go down Howard, when you see 5th and you see the Chief, it's right before the awesome graffiti. And you'll see a sign that says TechShop, and there's a parking lot in between. It's kind of hard to miss. It looks like a placemaker.
And do you do it each Saturday?
No, this is it. We worked all last week. We stayed up all night and all day today, and just to get these people through it. Yeah, it's what it is. It's a guitar hackathon. Never mind. Yeah. Cool. Any more questions? Go ahead.
You mentioned about the blue points coming horizontally versus vertically. Is there other cases where it's of great utility to kind of fine-tune the edges of your string or pencil string? Yeah.
Totally. Totally. I didn't bring it tonight, but we've made several cardboard chairs, and as long as you glue them along the x-axis, or you glue them along the x-axis. That tensile strength can hold up anybody. We've taken them to maker fairs, had 300-pound people sitting them, totally fine. So those are cases where it's great. Also, if you're going to use any sort of epoxy on it, you can do that. You asked about 3D printing fabric. I just wanted to share that one thing. There are people doing rapid prototyping fabrics. It's a different type of CNC where it's a spinning loom. So it's a loom fabric, and it actually shoots it out into the shape it's supposed to be. It's really in development. I know some shoe companies that are working. People are making dresses. Yeah. Yep. And they are making 3D printed dresses and all of that stuff too. There's a great article on the 3D printed bra, which I don't think anyone would ever wear, but it's a cool thing. And actually, I'm trying to do 3D printed shoes to do this race in. But go ahead. No. So your $125 a month gives you access to the best community in San Francisco by far. I challenge you to that. But it also gives you access to all the design computers. It gives you access to all the hand tools. And then you get a special discount as a member on classes. All your materials are in the shop. We have a little store in front. And we also get discounts through local, if you go to McBeath, I think they give you 10% on the... Yeah. Oh, the guitar itself ended up costing people that were really interesting about it went and got carbon fiber scraps from a guy that does it up north, and they got that for free. But it ends up costing in general about $500 when you get all the guitar parts are expensive. Yeah, especially we thought we're going to 3D print that. We're not going to 3D print that. They're expensive. Like tuners are $75, man. Yeah.
What material is that cardboard made out of? Is that
Aluminum.
Can you make a 3D carbon composite? I don't think you made a.
Okay, so the next project we're doing is we're talking about today just before I came here. Is we're working on that and looking at what if you 3D printed something, put epoxy and carbon fiber in the middle, and then 3D printed the outside of it. That way you get the shape you want, you get the strength of the carbon fiber. So we're going to try to build skateboards. That's the next workshop. I will, if you join TechShop, you can do it. If you're interested, I would go to TechShop in about 2 weeks because it's going to take us a week to. We usually go through it the whole thing at least once to find out. Hey, we made a bunch of mistakes, or hey, Blaine glued his hand to my shirt again. Like yesterday, I glued my keys together, which was not fun. Yeah. Let me go this guy. Yes. Yeah, I didn't get into any of the high-end stuff that Autodesk does because I work with a consumer group a little bit more, but they have things. They have all sorts of things. You have no idea. They have a thing called Navisworks, which does simulation of strength testing. We have a really cool thing with it's a wind tunnel generator. So if you do a catch of your head and then you put it in the wind tunnel generator, perfect haircut, which happens to be this one. It's not. There's probably better haircuts for wind resistance, but I don't know what I'm saying. Yeah, but there are things with different strength tests in it. You can put different weights on it. You can see where the hinges are going to break. Even in Inventor inherently, there's a little bit of that stress testing. What I would caution against, if you're a new maker or a new builder, is over-stress testing. I had a guy that spent 6 months at TechShop building a bookshelf, and the stress test never came out right because if you put in the wrong numbers, you get the wrong numbers out. And he ended up building a bookshelf with 1-inch thick plywood that could have been 1/4 inch thick, just because he just couldn't imagine doing it without the numbers in. That is actually free. So Autodesk has this other thing that's really great. It's called Autodesk Labs. You can go to their website. I think it's Autodesk. I think it's .labs.com or .com.labs. If you just search on the site, it'll show you. And on there is a bunch of free programs that we're testing out that you can try out. And that one's called Project Falcon. And we also have a cool exhibit that's a traveling exhibit for that, where you can get on a bicycle and ride it, and it'll show you the wind tunnel simulation next to you of different positions that you get in. Yeah, so you import an STL. The founder of TechShop uses it for his Pinewood Derby cars, which drives me nuts. But yeah, so his kid's always the best Pinewood Derby car. He knows exactly how to make them, and they're gorgeous. But yeah, wind tunnel simulation. It's a little over the end. Yeah.
Just think of a company called Motion. Do you have plans, or can you interface moving devices to this one?
What do they do?
It's like
Oh, yeah. I see what you're saying. I wouldn't see why you couldn't do that. I've never tried it, but it seems like it would work with the program because it's reading your fingers as a mice, right? So you could just say this is, a 2-click. And... Oh, wow.
I'm wondering if this would be cool for this.
Sure. Whatever. Yeah. I think it'd be cool. Can you say it again?
Leap Motion? They're down to sell them.
Leap motion?
Leap Motion.
Okay, thanks.
I saw them on an airplane somewhere. Yeah, I thought it was neat. But yeah, I haven't seen a lot as far as like we're on our development side about haptics or anything with just using your hands for motion control.
Do you know if there's any activity around electronics?
Electronics?
Printing and
Yes, so someone came out 3 weeks ago, and forgive me because I'm totally unresearched on that side of it, but they did come out with conductive printing material, and they're still testing it. But I think you're going to see that probably next. And then with CNC, we've done a lot of CNC etched circuit boards, which are basically writing something in a program like Eagle or I would say AutoCAD Electric, but I don't think that's what it does, and then sending it to a CNC utility, which is cool. If you're into circuit boards, you're like, yeah, circuit boards. Also Arduinos, if you get into that stuff. That stuff's awesome. And then mix it with some of this.
do you see that happening now?
Yeah, we see a lot of people mixing Arduino with everything. We're going to do a second iteration of the car and bring an Arduino into it to have it Arduino controlled. Because it's just such a powerful tool and such an easy tool to master. If anyone doesn't know what an Arduino is, it's a microcontroller. What does that mean? It's a small box that can control motors, lights, sensors, you name it, and all the codes to do all of that are online in a shared community. Projectors? Sure. It really could control anything. It's just a matter of how you set it up. And there's another one called Raspberry Pi that just came out that everyone's really excited about that kind of does a similar functionality. One more time.
I have they're like plastic piezoelectric materials.
Yep.
I believe. Can you 3D print that sort of thing?
That's what I believe they're testing out with, is some of the piezoelectric stuff. I'm not sure where it is right now enough to tell you, enough about it, but it's pretty easy to Google it or whatever, and there's some interesting articles.
So is this like retesting the surface or apologizing the surface and working or
Yeah, that's exactly what this algorithm is specifically doing is tessellation of surfaces is basically putting a triangulation mesh on it. And so this program is actually knocking down that to a foldable form and then putting seams in where they fit onto the paper.
Do you typically see people go to like an industrial grade? Like, do they start here maybe and then they take the files and move them into more of the professional software?
I've seen it a couple times, but most of the time, there's this thing called design constraint. So if you're new, okay, so for instance, when I went to college, all we had was a vacuum former. I can use a vacuum former to build anything, and I literally mean anything, because that was all I had. And people that start with this stuff tend to just keep using it. When they get to that point where they really need strong dimensioning, they might switch over to get very precise measurements in a higher end program. But most likely, CAD's sort of a religion. If anybody gets into this stuff, you tend to stick to your religion. And it's a strange phenomenon with CAD. It's not something like you see with vector programs. Well, it is a little bit. You don't see a lot of Illustrator users going to Corel just because it's fun. I'm a freak, so I like to use them all. But most people that I know, they go with one, and that's their thing.
Are the files that come out, are they readable?
Out of this, this puts out PDF files and DXF files. So they're readable by like a laser cutter or a plotter.
Those stereolithography files are not.
That doesn't come out of this. That comes out of the other program. So if, out of design or almost any CAD program ever, you can get STL files, which are stereolithographic. No, they're .stl, and that's what that is. It's a whole different file type than yeah.
Can you talk about the biomaterial?
Yes, thank you for bringing that up. So bio 3D printing, as I know it, it really revolves a lot around, it's an additive process. So it's a matter of dripping a material that assists in the growth of other materials by connecting to its DNA or connecting to its base structure. It's not CNC. It's not something that sits on a machine and that gets built up. So the kidney that people probably read about that was printed, it starts as a small piece of something, and then they're continually growing by adding on what you could call a sugar solution of sorts that kind of builds out on that structure. Does that help at all? I don't. I can't say I'm not an expert in that at all, but it's what I know of it is that.
Could you speak about the kidney? I didn't read about the kidney. I don't know.
Yeah, hold on one second. There are people doing some weird 3D printing stuff, or positive, or I would say prototyping with fungus. I don't. Yeah, I met a guy that makes fungus bricks and builds stuff out of that. I mean, there's this stuff's wide open as far as weird things that people want to do with it.
Could you speak about the kidney? I never heard of it.
The kidney was just it was a test. I totally blanking on who created it, and
It's not live, kid. It's not a live.
it's live. I mean, it's a functioning kidney.
It is a functioning kidney.
Yeah.
Really? Was it used? Is it?
They're in way alpha stage testing. I mean, it's not thing that you'll find on the market.
But
And what market are you going to?
what?
Nothing. Go ahead.
I didn't hear you.
No. Go
I
ahead.
don't want to miss a word.
Okay.
The ultimate goal is to create a kidney that could be implantable.
I would assume that, or it's to create a weird alien race of kidneys that jump around and attack people.
How close do you think this
From everything I've known, it's probably, I don't know. I don't know. I can't really answer that. I'm way far removed from the bio people. What I can say is if you go to the gallery, there's this awesome piece in there that is 3D printed, and it's just separate pieces in a beaker. And if you add energy by shaking it around, those pieces auto-collect into the object. And it's awesome. Yeah, and they're not magnetic, and it's just the way they're shaped because of the bioscience behind it. Yep.
Can you create compound surfaces in this program?
Define compound surfaces.
Okay, I use Autodesk on web, and you can pull CVs and pull hills and valleys.
Totally. Not in that way. Just like as
I
in
wondering how it does it. Is it more SolidWorks-esque? Is it more?
neither. It's really its own.
Yeah.
It's definitely its own animal, and it took me a while to to convert my brain to thinking like this. But I think for new people, it's really easy to do that. So for this, if you were going to do I don't know.
If I wanted to sculpt a fish.
If you wanted to sculpt a fish, you would start off with a basic extrusion of a fish and kind of wrap that down in by the filleting options in here are amazing. And basically, you take it down with a G2 fillet. What's called it? It's not a G2 fillet in this, but it's what you and I know as a G2 fillet. Yeah. Does that make a little bit of sense? It's definitely strange. I can show you some other stuff later if you want.
What's the weirdest thing you've seen made? Just in the past
Ever?
5 years?
Yeah, since you've been there.
Ever.
Good question. Since you've been there.
The car is really cool.
Yeah.
Yeah.
What's the weirdest thing?
It was the car. It was the weirdest thing. No, by far not the car. We have a lot of artists come in. It's San Francisco. I mean, we get a lot of weird things that way. I think the coolest weird thing was there's a guy in Menlo who made a diamond printer, and it was a CNC operation. He used, I forgot what he used. It was some sort of carbon gas, and basically printed out what, for all intensive purposes, was a diamond. And when we asked him what he wanted to do with it, he said, "Make a diamond for my wife." And it was like, it's just one of those things that's, they worked out okay. There's a cool shot of him on the TechShop website, and it talks about his story a little bit, and it's, it's a little tiny diamond, and
Is it beautiful?
it's beautiful, but the process he uses, we wouldn't let him do it at TechShop. And if we don't let someone do something, it's kind of on that fringe of, you might blow up your house, but you might print diamonds. And we're okay with both, just not here. So there's a lot of that goes on in San Francisco, especially with people that want to do like anodizing. There's a lot of things that San Francisco doesn't allow, and that's fine because it's not a need, wouldn't that be cool if, so we kind of send those other places.